Hi friends, so today I am starting in second year physics, that is 11th chapter, atoms. Okay, so all these comes under, I told you already, modern physics only, atoms. So from this also hardly 1 plus 1 mark, because already I told you dual nature, atoms, nuclei, all these together comes under 5 to 6 marks in MCET. So because all these are in modern physics, dual nature, atoms and nuclei. Now let us see the basic concept of atoms. See, regarding atoms, if you go to the history, that is from Dalton's theory, first one. Okay, first one is Dalton's theory of atomic model. So first model given by this scientist. Okay, so this scientist, I think around 1803. Okay, 1803. If you want the year, you can see from the books. Around 1803. Okay, this concept first designed by Dalton, but according to him, he has not given any basic things regarding this one atom. He told that it is a tiny particle. It is a tiny particle with no internal structure. Tiny particle with no internal structure. So this was the first model given by the scientist Dalton. Dalton's model em cheppadante, it is a tiny particle, okay, and no internal structure. So that means there is nothing explained regarding. It is a tiny particle, no internal. That means they have not defined any nucleus or electron or proton. Anything is not defined. That was in 1803. So later on, in 1897, that is Sir J.J. Thomson, Sir Joseph John Thomson, Sir J.J. Thomson, he has came forward with his model. So according to J.J. Thomson model, what he has compared is, he has compared with some watermelon. So according to J.J. Thomson, what he has designed is, he has compared the atomic model with a watermelon. With a tarbuja. Watermelon and a tarbuja. So if you see the watermelon, inside the melon, flesh will be there, red flesh. Inside that, the seeds will be there. So what he has assumed, J.J. Thomson, in 1887, okay, around 1887 or 1897, please. 1897, okay, in the year 1897. According to his assumption, all these are assumptions only, not correct. Later on it was proved to be wrong. So what his assumption was, just like watermelon, how the seeds are inside the flesh, those seeds he assumed that as electrons. Those seeds he assumed as electrons. But later on this was also proved to be wrong. So after these two scientists, another scientist, Rutherford, okay, in 1911, third scientist, Ernest Rutherford, what he assumed is, yes, okay, there is some nucleus inside at the center. There is nucleus at the center and electron is revolving around the nucleus and it has to rotate continuously, finally radiate energy, and radiance should be decreased gradually and finally fall into the spiral path. This was his assumption. Electron is revolving around the nucleus. Nucleus is at the center. Okay, and you all know nucleus. Inside the nucleus, what are present? Nucleons. Later on it was discovered. Nucleons and enti protons, neutrons. Okay, we all know inside the nucleus emuntayi. Nucleus lopala protons and neutrons, electrons will be revolving around. Later on those are discovered by other scientists. Okay, like Chadwick and other scientists. So here and Rutherford do, electron will revolve, continuously radiate energy, emit energy, and reduce the radius, and finally go into the spiral path. But this was also again proved to be wrong, given by Rutherford. Later on, a scientist named Professor Niels Bohr. Okay, So that is called as Bohr's model of atom, please. Clear? So Dalton has given only basic thing, that is, it is a tiny particle, no internal structure inside it, and according to other scientists, watermelon is assumed, that is according to Sir J. J. Thomson, Sir Joseph John Thomson in 1897, and the seeds inside the watermelon is related to the electrons. That was also wrong. And later on, Ernest Rutherford in 1911 he assumed that that electron is revolving continuously, emitting energy, and finally reducing the radius and falling into a spiral path. So later on, these theories are also proved to be wrong. Here's this Rutherford also done alpha scattering experiment. Rutherford also done the alpha scattering experiment. But what happened is, from this experiment with gold foil, alpha scattering experiment with gold foil. So with this experiment he has got some confirmations that electron is revolving. But what happened is, there was some defects in this Rutherford's also, because Rutherford told that electrons should revolve around the nucleus, and continuously radiate energy, and finally the radius is reduced and it has to fall into the spiral path. But that was wrong theory. So what happened, Niels Bohr, another scientist, Professor Niels Bohr, he has given two postulates, very important postulates. Niels Bohr has given very important postulates. Entante, electron while revolving around the nucleus, it may radiate energy, but it won't fall into the spiral path. It is rotating in a particular orbit. Electron is rotating in the particular orbit. But it won't fall into the spiral path. Why? Because the centripetal force, that is Fc, mv square by r, is helping without falling into the nucleus. Whatever Coulomb force is there between this nucleus, whatever Coulomb force is there, we all know what is Coulomb's force? Attractive force, that is K, Q1, Q2. Q1, here Z is what? Nucleus 1, Z is the nucleus 1. E is the charge of the nucleus. So ZE into E, by distance R, that is R square, which is equal to K ZE square by R square. So this Coulomb force is balanced by the centripetal force without falling into the nucleus. So this force is helping that one, the centripetal force, not to fall to the electron into the nucleus, please. Clear? So like that he told in the first postulate. And second one, while rotating, the angular momentum L, that is equal to mvr, is equal to nh by 2 pi, where n is the orbit number 1, 2, 3, 4. N is what? Orbit number. That means in which orbit the electron is revolving. So these are very important postulates given by Professor Niels Bohr. While rotating, it won't fall into the spiral path because the centripetal force is helping the Coulomb's force. And the angular momentum is equal to nh by 2 pi. H is Planck's constant, n is an integer which can take the value 1, 2, 3, so on and so forth. And n is nothing but orbit number, please. So with these postulates, finally he has succeeded, Professor Niels Bohr, in explaining the model of the atom. Right. Clear? Now let us go still further. So in EAMCET questions and NEET, we are getting a regular question, that is distance of the closest approach. In the examination, they are regularly asking the closest distance of approach. Closest distance, that is D minimum, of approach. So as we know, alpha scattering experiment, alpha experiment from Rutherford, we know what is alpha particle He24. He24 means what? Atomic number 2, and this is mass number. So it contains 2 electrons and A minus Z, that is 2 protons, and of course 2 neutrons, alpha particle. So what happens is, this alpha particle, when it is coming, when this alpha particle is coming, okay, with some velocity, and when it is hitting the heavy nucleus, when it is hitting the heavy nucleus, which you can take it as gold foil, heavy nucleus, nuclei, let the charge be Ze, let the charge of the whatever heavy nuclei be Ze. This is at rest, please. This is at rest. Ze is the charge. Okay? We all know what is meant by Z, atomic number. So E is the charge. Okay? And when it is coming from large distance, large distance. So from large distance means what happens? Potential energy is 0. So what is the total energy of this one? Total energy is equal to PE plus KE. That is 0 plus half mv square. But when it is coming, it is also having positive charge, and this is also positive charge. Both will be repelling. This is a heavier nuclei. This is a heavier nuclei. So when it is coming towards, what happens? It is having some velocity. It will try to repel because both are same charges, positive charge, positive charge. But still it is having some velocity. It will be dragging, and somewhere it will be stopping over here. Okay? At some point. When it is stopping, the final velocity will be 0, and this is the closest distance of approach, D minimum. That we have to calculate now. So when it is stopping here, what is the total energy here? Kinetic energy is 0. And what is the electrostatic force between them? What is electrostatic force? Okay? Force is nothing but 1 K into Q1 Q2. That means what is the charge here? 2E into Ze by D. Please, we know what is K? 1 by 4 pi epsilon naught. So this is the force. This is the potential energy also. Electrostatic potential energy. Okay? This is also called as electrostatic potential energy. 2E charge of the alpha particle, and Ze is the charge of the heavy nuclear. So K constant, K Q1 Q2 by D from electrostatics chapter. So 2E into Z, that is nothing but what is the force here? Force is equal to Z 2 E into E square by D. So what is the total energy now? Kinetic energy alaga 0 అయిపోయింది. So total energy ఎంత అవుతుంది? This total energy, this thing should be equal to here before, after conserved. So before energy anta PE plus this thing half mv square. So here I will be writing total energy before, that is half mv square, is equal to total energy after stopping. Stopping ante kinetic energy 0, only potential energy is there, electrostatic potential. Entadi Z2E square by D, of course constant is there. Clear? So from this it is very clear, you can see half mv square is equal to constant 1 by 4 pi epsilon naught 2ze square by D. This formula you have to remember for the examination point of view, because this D is called as closest distance of approach. In the exam they may be asking, this distance depends upon what? Mass of the particle. Mass is inversely proportional to distance, or distance is inversely proportional to mass. And also, second point, velocity, square of the distance is inversely proportional to the closest distance. Clear? So these two formulas are very, very important in NEET examination and also MCET. Closest distance of the approach is inversely proportional to square of the velocity and inversely proportional to the mass. Clear? Right. So this is about the closest distance of approach, please. Very, very important regarding examination point of view. Closest distance is inversely proportional to mass and inversely proportional to the square of the velocity of the alpha particle, what it is coming and hitting, trying to hitting the heavy nuclear. Clear? Now, in the same fashion, let us try to go forward with the subject, and we will try to find out what is the radius of the orbit. Okay? How to find the radius of the orbit? So we all know this is the nucleus. So this is the electron revolving. This is the radius r. Okay? So according to Bohr's postulates, we know first one, Coulomb's force, and then what is Coulomb force? 1 by 4 pi epsilon naught into Q1. This is what? Ze. Okay? This is the charge of the nucleus. Ze into E. Don't write minus because it is Coulomb's force, attractive force. Ze into E by R square. Equation 1. And what is centripetal force? This is Coulomb's force, and this is centripetal force. mv square by R. Equation 2. Okay? Centripetal force enti? mv square by R. Clear? And one more thing. What is second postulate? Angular momentum. mvr is equal to nh by 2 pi. Where n is an orbit number. 1, 2, 3 values. This is another equation. Okay? So, this is the angular momentum equation of the Bohr's postulate, and this is Coulomb's force. Clear? Now we will try to solve this one by taking these two equations into consideration. That's the point. So already we are having here, see here, mvr is equal to nh by 2 pi. Okay. So from this you can get what is V or what is R. Because R kavalante you can get R is equal to nh by 2m v pi. And already you are having Coulomb's force. What is Coulomb's force? 1 by 4 pi epsilon naught into Ze square by R square. Are you following here? If you compare these two, you will get one more equation. Chudandi. Centripetal force, see, I am writing here, mv square by R is equal to 1 by 4 pi epsilon naught Ze square by R square lonchi. If you compare this, what happens? You will get one value for R. Okay? And if you take the angular momentum equation, you will get one more equation. If you substitute here, this equation in here, if you put this R value here, then you can calculate V value. Because that's the point. When you put here, చూడండి ఇక్కడ నుంచి ఏమైంది ఒకసారి చూడండి, mv square by 4 pi epsilon naught equal kada, sorry, this is equal here. So here what happened, mv square is equal to 1 by 4 pi epsilon naught Ze square by R. Okay na? Now from this, if you put this value R here, 1 by 4 pi epsilon naught Ze square by this R value, that is nh by పైకి వెళ్ళిపోతుంది 2mv pi. Okay? So when you substitute all these values, you can see you are getting V value, you will get V value. In the same value, if you put V value from here, ఇందులో నుంచి V value ఎంత అవుతుంది? From this, what is V value? nh by mr 2 pi. If you put V here, you will get R. Because you are concentrating mainly on MSET, we are not deriving all the things. Just I am telling how to applicate. So R మీకు ఎలా వస్తుందండి, ఇంచుమించు value around 0.529 angstroms you will be getting. Okay? Around you will be getting 0. That is n square by Z 0.529 angstroms. This is the radius of the orbit we will be getting, final result. Okay, I have substituted the two equations, r value, and from this second postulate of Bohr, if you put v value or r value in this one, you will get thereby radius or velocity. And you can remember this formula for numericals. And here n and enti ikkada orbit number. N is orbit number which is equal to 1, 2, 3 ground state, first excited, second excited, etc. etc. And Z is atomic number of the element. Z is equal to atomic number of the element. So 0.529 angstrom, 1 angstrom is equal to 10 per minus. This formula 10 per minus 10 meters. So this n square by Z into 0.529 angstroms. This is the exact value of the radius of the orbit. N square by Z into 0.529. Clear? In the same way you can get velocity also, please. See, velocity of the orbit, in which, with what velocity the electron is moving. You can calculate nearly. Okay? So that is velocity. If you substitute the same thing again, you will get nearly velocity is equal to Z by N into 2.2 in 10 power 6 meter per second. Again, Z atomic number of the element, N is orbit number. Okay? So you will get this value orbital speed. This is also called the orbital speed. Orbital speed. With what speed the electron is revolving. So Z by N into 2.2 into 10 power 6 meters per second. Same from here, from this equation only. Whatever equation I told you now, from that equation you can calculate. Okay? Z atomic number, N is orbit number. That means ground state, first excited, second excited, like that you can get the value. Clear? So 2.2 into 10 power 6 meters per second. Z is atomic number. See, you can get reverse here. R is equal to N square by Z. You get Z by N untundi. This you have to remember. Clear? Right. In the same way, in examination, as I just now I told you, the electrostatic potential energy equation and also kinetic energy. Okay? Just now I told you, electrostatic potential energy. I have given the equation for you. Into potential energy, K into, what is that one? 2E ZE by R. Electrostatic potential energy, the distance square of the R. This is potential energy. K. K means you know the value. 1 by 4 pi epsilon naught constant. And this one finally emutundi K Z 2E square by R. This is electrostatic potential energy. And you also know kinetic energy formula, half mv square. And already you have know the V value. Okay? When you substitute all these values, and total energy, we are finding for total energy, potential energy. Okay, we are finding out what is the total energy in that orbit, potential energy, and of course kinetic energy. So if you substitute all this, you will be getting potential energy because as I told you, potential energy can be negative, but kinetic energy cannot be negative. Okay. So when you substitute the value, you will be getting around minus 27.2 Z square by N square electron volts. This is the final value of getting potential energy. Okay, minus 27.2 Z square by N square. Atomic number Z. Z is atomic number, N is orbit number. And in electron volts, already I told you, electron volt will be using in modern physics, not for joules. In the same way, kinetic energy allows the Ke is nothing but, I am talking about magnitude, half of potential energy, please. I am talking about magnitude. Therefore, because kinetic energy cannot be negative, half of magnitude, that is 27 point how much? 2 13 is 26, 6 is 13.6, and it is plus 13.6 Z square by N square electron volts. This is the kinetic energy. Now again total energy. See, total energy magnitude is equal to magnitude of kinetic energy. So total energy magnitude ఎంత అవుతుంది? ఈ రెండు ఒకటే, but generally total energy will be negative, same value, minus 13.6 Z square by N square electron volts. Please remember the total energy. You can get all the values. Total energy వస్తే kinetic energy వస్తుంది, kinetic energy వస్తే potential energy, because kinetic energy half of potential energy in magnitude. Kinetic energy equal to half of potential energy. Please, I am writing here kinetic energy in the orbit, okay, is equal to half of potential energy magnitude. And total energy, kinetic energy are equal, but kinetic energy is a positive value. In the orbit. And the minus 13.6 Z square by N square. Clear? And these are very, very, very important during numericals in this atoms chapter, please. In the orbit. That means if an electron is jumping from higher level to lower level or lower level to higher level. Very, very important thing here. Now, before going into the next one, I'll try to tell you regarding ground state, excited state, some points. Okay. For example, this is ground state. Ground state n is equal to 1. N is equal to 2. First excited state. N is equal to 1. N is equal to 2. N is equal to 3. Second excited state. This is first excited state. N is equal to 4. Third excited state. N is equal to 5. Fourth excited state. And finally this is infinity. Okay. So first of all you have to know this is ground state. So in ground state, what is the energy? First of all, at least minimum up to 3 to 4 values you have to put in your mind. So in ground state, the total energy into formula minus 13.6 Z square by N square electron volts. Suppose if you take hydrogen atom. If you take hydrogen atom, what is the atomic number? 1H1. So Z is equal to 1. So minus 13.6 1 square by N. Ground state lo undi. N is equal to 1. 1 square electron volt. That is equal to minus 13.6 eV. So for a hydrogen atom, if you take in ground state, what is the total energy? Minus 13.6. Let us go to the first excited state. First excited state ki veldam. In first excited state, we'll put the value minus 13.6 Z atomic number 1 whole square by N. N is equal to 2. That is 2 square. That is minus 13.6 by 4, and that is equal to 4 3s are 12, 4 4s are 16. That is minus 3.4 electron volts. Which is greater of these two? 2 is greater. 2 is greater than 1 energy. And the energy is more in the second one. Then because chudandi ikkada idu minus 13, idu minus 3. It is approaching 0. So that means it is indicating as you go high, energy what happens? Energy increasing. As you go from ground state to higher state infinity, the energy is increasing state. You can see this very, very important point. Energy is increasing, total energy. Total energy is increasing as you go from ground to the infinity. Now let us go for third one, second excited state. Let us try to understand all this. In second excited state, minus 13.6, first one, second one, N is equal to 3. Atomic number hydrogen 1 by 3 3 square 9. So minus 13.6 by 9, that is 9 ones are 9. How much? 46 is there. 9 5s are 45. 1 is there. 0.91. So point shift అయిపోతుంది 1.51. 1.51 minus. So minus 1.51 EV. See? Minus 3.4 minus 1 point. So it is an increasing state. So here the energy is how much? Minus 3.4 first excited state. Second excited state, what is the energy? Minus 1.51 electron volts. So as you go up, the energy is increasing. Let us find the third one also. Third excited state, again minus 13.6 1 square by ground first, second, third and 4 4 is 16. So minus 13.6 by 16. 4 4s are 4 3s are 12. 4 4s are okay. 2 2s are 2 17s are 2 8.5. Pointing it shifted 0.85 minus. So here minus 0.85. So the value decreasing. Now you can calculate up to the whatever orbit you want. So at least some values you have to remember in your brain. Ground state minus 13.6, first excited state minus 3.4, second excited state minus 1.51, third excited state 0.85. If you want the fifth one also you can calculate, that is fourth excited state, third, fourth excited state, fourth excited state, that is minus 13.6 1 square by 25. You can calculate this also, okay. That is, I will write this one, I will rub the above values. See, try to remember these values in the examination. They are asking from ground state to at least up to third or fourth excited states. These values make chala important. I will write it somewhere over on the right side after completion. So, this is minus 13.6 by 25. So, when you divide with 25, what happens? You can try 25 6 are 150, 25 7s are 7 5s are 35, 5 3, 70s are 14, 15 16, 17. So 6s are, let us go with 6. 25 6 are 150 ఎక్కువ అయిపోతుంది కదా. 25 6 are 25 4s are 100. 25 6 are ఎంత అవుతుంది? 6 5s are 30, 150 ఎక్కువ అయిపోతుంది. So let us go with 4. So these values, if you remember, it is very easy to solve problems. So 25 5s are 25 5s are అవుతుంది కదా. 25 is 125, 6 are 125, so 5 times. So 136 lo 125 if you remove, 1 is there, 0.0, okay. 25 again, 5 is 125, 24 is 100, again 4 is 100. అంటే పాయింట్ ఎక్కడెక్కడ షిఫ్ట్ అవుతుంది చూడండి. ఆల్రెడీ పాయింట్ ఈస్ దేర్ by 10, 10 to the power minus 1. So 0.544. So this value anta indi? Of course it is minus 0.544 electron volts. At least these values have to put in mind. Ground state of hydrogen atom minus 13.6 eV, first excited state minus 3.4, second excited state minus 1.51, third excited state minus 0.5, and fourth excited state minus 0.5. See the value as you going to the infinity from ground state, the value is increasing. So minus 3.4, minus 1, minus 0.85, minus 0.5, like that is going towards to 0. So the value is increasing. So total energy value increases as you go from ground state to the higher level. These values are very very important. I will be writing somewhere over left side or right side. In the examination they may be asking. Okay. So cherpestunannandi idi. Should I rub it? Okay. Now we are coming to the next point, that is Rydberg constant and energy, excitation energy. Excitation energy. Okay, ఇక్కడ రాసేస్తాను మీకు better so that you will remember. Ground state value is minus 13.6 eV. First excited state value minus 3.4, second excited state minus 1.51, third excited state minus 0.85, fourth excited state minus 0.5. So this is from down, ground state idi. So as you are going from ground state to top, the value is increasing. Total energy value increasing. These values you have to put in your mind. Minus 0.54 electron volts. Okay, clear? Now let us see what is meant by. I will put this one, I won't rub because this is again important. Next one is photons, that is excitation energy. excitation energy. What is excitation energy? See, we all know when sufficient energy is given to the any metal, electrons are evolving. You have seen in photoelectric effect. So when electron is jumping from lower level to higher level, it absorbs energy. When it jumps from higher to lower, it emits energy. అర్థమవుతుందా మీకు? సో ఎక్సైటేషన్ ఎనర్జీ అంటే ఏంటి? when electron is jumping from lower to higher level, absorbs energy. Absorbs energy from lower level to higher level. First orbit, ground state to first excited or first second, energy is absorbed. Okay? Or when higher level to lower level, high నుంచి లోకి జంప్ చేసినప్పుడు it radiates, emits energy or emits photon. Emits energy or emits photon. Okay? We have one formula also. How many photons are emitted? N into n minus 1 by 2. A small formula is there. How many photons are emitted during the jumping? N into n minus 1 by 2. Number of photons emitting. This formula you can utilize for examination. How many number of photons are emitting? Okay? N into n minus 1 by 2. Clear? Right. Now by using this formula, we will see what is Rydberg constant and how the formula will be changing in excitation energy. చూద్దామా? Right. చూడండి ఒకసారి. We all know what is the total energy formula in the ground level, ground state, minus 13.6 Z square by n square electron volts. This is general equation of the ground state. Now suppose an electron is jumping from here to first excited state. Now I will see what is the energy. Excitation energy. Excitation energy. Okay? U final minus U initial. That means total energy. Total energy final minus total energy initial, please. Total energy final. Total energy final minus total energy initial. Final ikkadi nunchi ikkadiki vellindi. So what is the final energy here? A stage, first excited state. That is minus 13.6. Let us calculate for hydrogen atom only. That's why I am taking Z is equal to 1H1. Okay? By A state first excited state means in the place of N, N2 square minus initial total energy minus 13.6, again Z square, 1 only will put. Okay? A state from initial into N1 square. Now see what happens. Energy delta, excitation energy delta is equal to minus 13.6 Z square by N2 square, minus into minus, plus 13.6 Z square by N1 square. Now from this I will take common 13.6 and Z square common, inside 1 by N1 square minus 1 by N2 square. So this is the standard formula for delta E, that is change in energy from lower to higher. Okay, that is final minus initial. అలాగే హై నుంచి లోకి వెళ్ళినప్పుడు కూడా అలాగే చేయాలి. when you are coming from high level to lower level also, total energy final minus total initial. So this is the final formula, please. Very very important. 13.6 Z square into 1 by N1 square minus 1 by N2 square. N1 is the orbit number, first number, అంటే ground state అవ్వచ్చు, లేదా వాట్ ఎవర్ ద ఇనిషియల్ వన్. N2 is the final one. Clear? Now from this we will explain Rydberg constant also. From this we will try to explain Rydberg constant. Now this is energy actually, energy difference. Delta E is equal to energy kada. Energy I can write as H nu or Hc by lambda. So what I will do is Hc by lambda is equal to this thing, energy 13.6 Z square into 1 by N1 square minus 1 by N2 square. So when you put Hc value here down, I will take it as 1 by lambda is equal to 13.6 Z square by Hc. H is Planck's constant 6.62 10 power minus 34 joule second. C velocity of light, that is 3.0 into 10 power 8 meters per second. Okay, అంతేకాకుండా we have one more standard formula also for this one. 1240 when lambda in nanometers, that is energy in electron volts. We have this formula also. 1240 divided by if lambda in nanometers, electron volts energy, or 12400 by lambda in angstroms. ఇది కూడా వాడుకోవచ్చు. You can use 12400 when lambda is in angstroms. Then the energy will electron volts, because modern physics law we won't use the Prescott joule unit, joule. The smallest unit will be used, that is electron volt. I told you 1 eV is equal to 1.6 in 10 power minus 19 joules. So, e factor you can use in solving problems. When wavelength is given in nanometers, electron volts energy is given by 1240 by, this is solid value of this equation, E is equal to h nu. Okay, so when you put this value, finally ఏమవుతుంది 1 by n1 square minus 1 by n2 square. So this one finally goes like this, 1 by lambda, this entire thing will go for r, and z square will be there other than hydrogen atom. Okay, if hydrogen atom is there, you can remove z, because for hydrogen atom atomic number is 1. Other than hydrogen atom, if it is there given, you have to put z square. Z square into 1 by n1 square minus 1 by n2 square. This is the final formula, including Rydberg constant. This r is called as Rydberg constant, and its value is 109,677.8 centimeter inverse, or simply 1.1 into 10 power 7 meter inverse. You can change that value. ఎందుకంటే 109,677.8 centimeter inverse ఇది. You can convert into meter also. When you convert, you will get it as 1.1 into 10 power 7 meter inverse. ఎందుకంటే తెలుసు కదా మీకు, చూడండి 109,677.8 per centimeter ఇది, per centimeter. But 1 centimeter ఎంత, 10 power minus 2 meters. 1 centimeter ఎంత, 10 power minus 2 meters. ఇది పైకి తీసుకెళ్ళిపోతే ఇంటూ 100 కదా, అప్పుడు ఎంత అవుతుంది ఇది, 109,677,800.0 1 2 3 4 5 6 7 వచ్చిందా? సో వాట్ హ్యాపన్ హియర్, 1 2 3 4 5 6 7. So with multiply with 7 divide by 7, అంటే 1.09 in 10 power 7 means what? Nearly from significant figures you can add 1 here. So 1.1 in 10 power 7 per meter or meter. This is the value, Rydberg constant. Okay, so like this you can use the formula, and thereby you can apply in the numericals. Clear? So except hydrogen atom, ఒకవేళ hydrogen atom అయితే z తీసివచ్చు, 1 by lambda is equal to Rydberg constant. Other than hydrogen atom, చూడండి hydrogen atom ఉంటే, if hydrogen atom is taken, then the formula goes like this, r into 1 by n1 square minus 1 by n2 square. Other than hydrogen atom is given, then 1 by lambda is equal to r into z square, atomic number of the unknown element, into 1 by n1 square minus 1 by n2 square. Very very important, and examination లో దీనికి సంబంధించిన ప్రాబ్లమ్స్ చాలా వస్తున్నాయి. Please try to understand, because I'll tell you later on, now after completing the last point, that is Lyman series, Balmer series, Paschen bracket and P-Fund series. After that one, we'll do one numerical also. That is the last one for the completion of the chapter. Okay na? Right. Now let us complete that one, and then we can solve one problem regarding the Rydberg constant formulas. Now last concept in this atoms chapter, that is different types of series. Different ante Lyman series, Lyman, Balmer, Paschen, okay, bracket, okay, Lyman, Balmer, Paschen, bracket, and again finally Fund series, P-Fund series. So all these are series. Different scientists, 5 scientists, Lyman scientist, Balmer, Bastian, Brackett, Pfund series. Okay? Even series ఎలా ఇచ్చారు ఒకసారి చూద్దాం. All these series. Okay? Lyman series, I think you can take it as in a UV region, ultraviolet. Balmer, I think you can take it in visible region. It is taken in visible, and remaining 3 are taken as infrared. Infrared region. Okay? So Lyman is considered in UV region, ultraviolet region. Lyman. Balmer in the visible spectrum or visible region. Bastian, Brackett and Pfund, all these 3 are considered infrared. Now let us try to draw a nice diagram for the series. Ground state, first excited state, next one, second excited state, n is equal to 3, third excited state, n is equal to 4, fourth excited state, n is equal to 5, and finally infinity. Now these 5 scientists, they have decided themselves. So what they have decided is, from whichever the line is coming, from infinity or 7th orbit or 11th orbit or whatever orbit the line is coming, it has to reach to my first state, that is ground state ki ravalani they have decided, Lyman. So for example, it is coming from here. For example, say it has to reach the ground state, or it is coming from here, second excited state. It has to reach the first one, or from here, first one, or from here, first one, or from infinity. So this series is called as Lyman series. And this is in which region? Ultraviolet region. So according to this scientist, what he assumed is, whichever line is coming from infinity or from 5th excited or 11th or whatever, it has to reach the first one only. First one into n is equal to 1, ground state. That series is Lyman. In the same way, Balmer, what he told is, in whichever region the line is coming, it has to come to my n is equal to 2. It has to come to my whatever state is coming. This is Balmer. This is Balmer series. And Balmer series is in visible region. It is in visible. అంటే ఎక్కడి నుంచి లైన్ వచ్చినా ఫస్ట్ ఎక్సైటెడ్ స్టేట్లోనే కావాలి, అది మీట్ అవ్వాలి ఫైనల్గా. సో ఈవెన్ ద ఫస్ట్ లైన్, సెకండ్ లైన్, థర్డ్ లైన్, ఫోర్త్ లైన్, ఎనీ లైన్, ఈవెన్ Lyman series, first line, second line, third line. In the same way, remaining people also, Bastian, Brackett, Pfund, what they told, it has to reach my third one. Third one. This is Bastian series. In the same way, Brackett, series. Fourth one, the same way Pfund, 4th excited state. Pfund series. Have you seen? So this is how the scientists have distributed themselves. Okay? So Lyman series ekkadi nunchi line vachina n is equal to 1 daki reach avali. Balmer series, from wherever the line is coming, it has come to n is equal to 2. Next, Bastian, n is equal to 3. Brackett, n is equal to 4. Pfund series, n is equal to 5. So this is how, and make a note, Lyman is in UV region, Balmer series in visible region, and remaining these 3 are in infrared region. Clear? Right. So this is how we can explain. We'll try to do a small numerical. The chapter is also over. We'll try to do a small numerical. Examination of questions ఎలా వస్తాయంటే, try to understand. See, in the examination they come like this. For example, first line of Lyman. First line of Lyman series. Wavelength is equal to second line of Balmer series. Second line of Balmer wavelength అంటాడు. First line of Lyman అంటే ఏంటి? First line ఎక్కడ ఉంది? From where it is coming? From n is equal to 2. So if you apply the formula here, lambda 1 by lambda is equal to r. Suppose hydrogen atom అయితే జట్ట వేయవసరం లేదు. హైడ్రోజన్ atom కాకపోతే మాత్రం you have to put Z. Suppose first line of Lyman of hydrogen, then you have to put, you need not put that value. Hydrogen కాకపోతేనే value, but because it is hydrogen, you can take one value కదా, 1 square, Z square లో, into 1 by N1. What is N1? Lyman always the N1 is the value constant. Lyman, what is N1? Ground state. That is 1 square minus, what is N2? Which line you are considering? ఏ line తీసుకున్నాం? First line. First line from where it is coming? First excited state. That is here N2 becomes 2. So 2 square. And this wavelength, suppose it is equal to the wavelength of any other atom. Then how you will take other atom ante 1 by lambda, okay, is equal to r into any other atom, because hydrogen atom అయితే Z రాయమన్నాను, other atom Z square into second line of Balmer. Second Balmer కి ఎప్పుడు కూడా n1 అనేది కాన్స్టెంట్ 2. సో 1 by ఇక్కడ n1 లో 2 స్క్వేర్ మైనస్ n2 ఏమవుతుంది? సెకండ్ లైన్ ఆఫ్ Balmer. యూ కెన్ సీ దిస్ ఇస్ ఫస్ట్ లైన్, దిస్ ఇస్ సెకండ్ లైన్. సెకండ్ లైన్ ఎక్కడి నుంచి వస్తుంది? n ఈజ్ ఈక్వల్ టు 4 నుంచి. సో n2 ఎంత అవుతుంది? 4 square. So like this you can equalize. So when you equate both of these wavelength, r gets cancelled. Okay, r gets cancelled. You can find the atomic number of that unknown element. అర్థమవుతుంది మీకు? This is one equation. You can చూడండి. This is one equation. This is one equation, and this is another equation. According to the question, both are equal. According to the question, both are equal. So therefore what happens? Therefore when you equate it, what you will have? When you equate it, ఏమవుతుంది ఇక్కడ చూడండి, and left side 1 by 1 అంటే 1 minus r get cancelled, 1 by 4. 1 by 4 is equal to right side unknown element Z square into 1 by 2 square, 4 minus 1 by 16, 4 square. So here 4 minus 1 LCM 3 by 4 is equal to Z square into LCM make it 16. 4 4s are 16 1s are. So ఇక్కడ 4 4s are 16. ఇక్కడ 3 left side, Z square into 4 minus 1 3 by 4. 3 3 gets cancelled. So I write it here. Z square is equal to 4. Z is equal to plus or minus 2. So if atomic number negative value లేదు కాబట్టి you can take Z is equal to 2. So answer is 2. You can take it as helium nuclei. So atom ఏంటిది? Unknown atom ది, you got it as atomic number as 2. 2 and ఎవరిది? Helium nuclei. Helium nuclei. He2 4. So like that you can calculate for any given problem. First line of Balmer, second line of Balmer, or first line of Paschen, or second line of Pfund. Any values if you given, you can apply the Rydberg values, except hydrogen. If hydrogen is given, you can take Z is equal to 1. Other than hydrogen, 1 by lambda is equal to r Z square into 1 by n1 square minus 1 by n2 square. ఒక హైడ్రోజన్ అయితే r into Z ప్లేస్లో 1 పెడతారు, రిమైనింగ్ ఆల్ ఆర్ సేమ్. ఓకే, క్లియర్? సో ప్లీజ్ ప్రిపేర్ వెల్ ఫర్ దిస్ సబ్జెక్ట్. Very easy chapter and small chapter atoms. From this you can expect, because I already told you modern physics and dual nature, atoms, nuclear, all together you will get 5 to 6 marks in MCET. If you take individually, you cannot tell, because they may give 2 marks in atoms, they may give 1 mark in dual nature, or they may give 3 to 4 marks in nuclear. So prepare well. Again we will be meeting in the next chapter, that is nuclear chapter. Okay, right.